Assalamualaikum, this is Fatima Arshad, roll number 002, program MSPT. Today, the topic of my presentation is edge computing. Here are the table of contents from the presentation, which includes introduction, how edge computing works, layers, usage, importance, and challenges. Here's the introduction. Edge computing. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of data. This minimizes the latency and bandwidth used while enabling real-time processing and data decision making. Edge computing processes data at or near the data source rather than relying on centralized data processing, warehouse, or cloud. The principle is totally straightforward. If you can't bring data closer to the data center, get the data center closer to the data. Basically, the edge computing concept is not new and it is rooted in decades old ideas of remote computing, such as remote offices and branch offices, where it was more reliable and efficient to place computing resources at the desired location rather than relying on the central location. How edge computing works. Edge computing is all the matter of location. In traditional enterprise computing, data is produced at a client endpoint, such as user's computer. So, the working includes a data source. Data is generated by devices, such as either they are the sensors, either the smartphones or IoT devices. Edge devices. These are the hardware and the software that process data locally. For example, you can include the routers, gateways, and even the specialized edge servers. Cloud integration. Process data that needs long-term storage or deeper analytics is sent to the cloud. Edge nodes. Intermediate points that further process the data before sending it to the cloud if necessary. As we know that there are a huge number of businesses that exist in our world. Each business has its own data. So the edge computing method is important to collect data, to source it, to interpret it, and to integrate it. Layers of edge computing. There are 4 layers of edge computing, which includes cloud layer. Cloud layer has components, centralized data centers. What its function is long-term storage. Comprehensive data analysis. Only a comprehensive amount of data is analyzed at the centralized data centers, such as cloud layer, and its management. The second layer is fog layer. Its components are decentralized infrastructure that suppose edge devices. Its function is intermediate processing and temporary storage. Then comes the edge layer. Its components include edge servers, gateways, and routers. Its function is data filtering, aggregation, and sometimes advanced analytics. Device layers. Device layer include all the sensor actuators and embedded systems, and its function is data generation and initial processing. Edge to cloud architecture is formed in this way. The first layer is the cloud layer, as it was explained before. The second layer is the fog layer, third layer is the edge layer, and the fourth layer are the edge devices, which can include any smart city, any business, any factory, any building, including the smart cities and mobile devices. Here is something an important note. It's important to repeat that fog computing and edge computing share an almost identical definition and architecture, and the terms are sometimes used interchangeably even among the technological experts. Uses of edge computing. Edge computing. Edge computing techniques are used to collect, filter, process, and analyze data in place at or near the network edge. It is a powerful means of using data that can't be first moved to a centralized location. Industrial IoT, how edge computing has benefited the industries. Reducing downtime by processing data locally to predict equipment failures. Healthcare in medicine enables immediate responses to critical health changes. Smart cities. real-time data processing to manage traffic flow and reduce congestion. Detail, local data processing for instant insights and recommendation. Importance of edge computing, reduce latency. It explains that local data processing minimizes the delay in the case of edge computing as the sources are near to the data. Its impact is phenomenal, essential for application requiring real-time responses. Bandwidth optimization. It means that less data are sent to the cloud, which reduces the bandwidth usage, which impacts that the cost would be lower and the efficiency would be improved. Third, enhance security, which explains that the sensitive data can be processed locally, which reduces the risk of data breaches during its transmission. Scalability, which explains that it distributes the computing resources, which supports large-scale IoT deployment effectively. Challenges in edge computing. Regardless of being so efficient, edge computing can face some challenges, which includes security, as it includes a large amount of data, so which can increase the risk of attack surface. The solution is simple: implement robust security measures at all layers. Data management. Handling vast amount of distributed data is hard sometimes. So solution is efficient data storage and management strategies. Third, network reliability. The issue can be depending on the local network infrastructures, and the solution is ensure redundancy and reliable network connection. Integration. The issue can be compatibility between different devices and platforms. The solution is developing and adhering to standard protocols. In summary, I would like to say that edge computing is revolutionizing how data is processed and utilized by bringing computation closer to data sources. It enables faster processing, enhances security, and it optimizes the bandwidth. Despite so many challenges, it is important in modern computing and IoT applications undeniably. These are my closing thoughts. As the number of connected devices continues to grow, the role of edge computing in creating efficient, real-time, and scalable solutions will only become more critical. Thank you.